Good morning, guys. Today in chemistry we will learn how to do the ionic bond by using Lewis' structure. Remember, ionic bond is, we basically don't have pure ionic bonds. But remember that we use the electronegativity table in order to see if we have ionic or covalent bond. In case that we have covalent bonds, what type of bond is that? Is that polar? Is that non-polar? So it's gonna do a couple examples for ionic bond. Now remember, the ionic bond is the one in which two atoms, they work together. They basically do a trade in which one says, okay, better lose my electrons in order to get a full the octet rule, in order to reach the octet. Now, what happens? One atom gains electrons and the other one loses. In this case, when it's about gaining or losing electrons, we talk about ionic bond, such as the one that we have between barium and oxygen. Now, if you remember, one of the first steps that we follow to build the Lewis structure is to build the electron configuration notation. In this case, I will build both, one for barium and one for oxygen. That is a process that you already know, but in case that you have forgotten, we always start from here, okay, until we reach, for example, barium, that is 56, the atomic number is 56. We need to follow all this pattern in order to get 56 electrons. Just recall that S is 2, P is 6, D means 10, and F holds up to 14 electrons. Now, for barium, it's as simple as 1 is 2, 2 is 2, 2p6, we follow, 3s2, 3p6, we follow, 4s2, we go back to 3d10. I know I have 30 in here, so I continue. 4p6, 5s2, now I go back to 4d10, and I have 48. Okay, 48 and 6 makes 54. So I continue, and I have 6s2. Now I have the 56 electrons. You can count all of them and you will see that we have the 56 electrons. So, what do I have to focus? In the last one, in the last row that we have right here, tells me the amount of electrons that I have in the outermost level. As I know that I have 2 electrons in the outermost level, I know my Lewis structure for barium will be its symbol and 2 dots. So right here I will have barium and 2 dots around it. Now I will do the same process, but for oxygen, which is number 8 in the periodic table. So I will do the same. I will follow the pattern here until I get oxygen. So I have 1s2, 2s2, 2p4. 2 and 2 makes 4, plus 4 makes 8. So how many electrons does oxygen have in the outermost level? I have 2 plus 4. I have 6 electrons in the outermost level. I know I wrote 2, but it's 6. 2 plus 4 equals 6 electrons in the outermost level. So how do I build the Lewis structure? Its symbol, and then 6 dots around it. 1, 2, 3, 4. That's what we do. First we do we build the first 4 dots, and then we do another round until we reach 6 electrons. So 4, 5, and 6. So as you can see, the Lewis structure for oxygen is like this. Now these dots are gonna do them differently. I will use blue in this case. So as you can see, we have 2 right here, 2 right here, 1 and 1. So as you know, in ionic bonds, we don't have sharing, we have given electrons. So that means that the metal, in this case we're talking about barium, or the one that has less electrons in the outermost level, is going to transfer those 2 electrons to the non-metal, which is oxygen. So this is what follows, and this 1 electron here will occupy one side of oxygen, and this other electron here will occupy this other side. So barium, it's gonna be alone here, losing 2 electrons. As it loses 2 electrons, the charge is 2 plus, and then for oxygen, we have oxygen right there, and we have how many dots around oxygen? We have 2, 2, 1, 1. Those were the original dots for oxygen, and now these 2 that are coming from barium. So how many electrons gained oxygen? Gains 2 electrons from barium, so that means that the charge is 2 minus. Now in this case, when we have all this, what we do is we transform to its ion form. So barium will be right here. We place it inside brackets, as you can see, and we write the charge 2 plus right here. And for oxygen, we're going to have oxygen, its charge is 2 minus, and the dots that are now part of oxygen are there, like that. So this is basically the Lewis structure for a bond between barium and oxygen. That one is okay. So as you can see, it's kind of easy. We basically apply everything that we have learned so far, and it's cool. Now we do a second example. In the second example, we have 1 magnesium and 2 chlorine. So basically what we're gonna do is we're gonna build a Lewis structure for magnesium and chlorine, 1 for each. Okay, so magnesium, which is number 12 in the periodic table, okay, we're gonna do the Lewis structure. So it's gonna be 1s2, 2s2, 2p6. I have 10 right now, so I need 2 more. I have 3s2. That means that I have 2 electrons in the outermost level, so the Lewis structure for magnesium will be Mg, which is the symbol, and 2 dots. Okay, so we write magnesium right here and 2 dots around it. Simple as that. Now we continue. We're gonna build the same map for chlorine, which is number 17 if I'm not wrong, and if I am, okay, I'm not wrong. Okay, so let's do the same for chlorine. So I have 1s2, 2s2, 2p6, 3s2. I know I have 12, so I need 5 more. So this is 3p5. Okay, we follow the pattern, remember? So that means that chlorine has in the outermost level 2 plus 5, 7 electrons. So the Lewis structure will be chlorine, that symbol, plus all the atoms, the 7 electrons around it. So it's gonna be 1, 2, 3, 4, and then 5, 6, 7. So as you can see here, we have 2 chlorines. So we're gonna do 2 chlorines. We're gonna copy the same Lewis structure, but twice because we have 2 chlorines right there. So we have chlorine and all the dots, 7 dots, and another chlorine right here. It doesn't matter where you want it, just place it where you want. Okay, now what's going to happen? As it is ionic bond, the metal will lose electrons. The one that has less electrons in the outermost level is the one that is going to give up electrons. So magnesium will give 1 electron to one of its chlorine, and the other electron is going to be for the other chlorine. So what is going to happen? Magnesium will be alone, loses 2 electrons, therefore the charge is 2 plus, and you will have 2 chlorines, because you have 2 chlorines over there, so you will have 2 chlorine, and this chlorine has 1, 2, 3, 4, 5, 6, 7 dots, plus 1 that comes from magnesium, because it is twice, remember, 2 times 1 is 2. So this means that chlorine gains 1 electron, okay? Each chlorine atom gains 1 electron. 2 times 1, it's 2. So the charge of chlorine is 1 minus. Each chlorine has a charge of 1 minus. So the Lewis structure, I'm going to do it here. The Lewis structure will be, in brackets, magnesium, outside the brackets, the charge 2 plus, because it loses 2 electrons. In here you will have 2 chlorine, and the charge is 1 minus. And here inside we're going to place all the dots that are around chlorine. And I always place the other one that comes from the other element in a different color. So this is the Lewis structure between magnesium and chlorine. Now for the third example, we have 2 aluminums and 3 oxygens. So the first step is we're going to build the electron configuration notation for aluminum and oxygen. Afterwards, we're going to do the Lewis structure for each atom, and then we're going to do the ions kind of things. So first we have aluminum, which is, if I'm not wrong, number 13. If I'm wrong, forgive me. Nope, I was right. It's number 13. So we're going to build the electron configuration for aluminum as 1s2, 2s2, 2p6, 3s2, and 3p1. Okay, yes. So electrons in the outermost level is 2 plus 1, 3. So basically aluminum is gonna be like that. As it is a metal, it's going to lose its atoms, its electrons, sorry. So as you can see, as we have two aluminums, we're gonna do it twice. Aluminum here and aluminum there, and each of them has 3 dots around it. Now I will do the same for oxygen. Oxygen is number 8, I guess. Yes, we just did it. But just in case that you have forgotten, the electron configuration is 1s2, 2s2, 2p4, 2, 2, and 4 makes 8. Electrons in the outermost level are 2 plus 4 is 6. So basically we have oxygen, and we have 1, 2, 3, 4, 5, 6 dots around it. And we're gonna do it. We're gonna write it 3 times because we have 3 oxygens. So I have oxygen here, oxygen there, and oxygen here. I'm doing this like this because of the space that I have. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And now what is going to happen? What is going to happen is that aluminum will give all its electrons away. So what's going to happen? This electron here is going to take part of aluminum, of oxygen, sorry, and this one 2. Now this one right here is going to the other oxygen, and this one here is coming to this oxygen. This one from aluminum comes from the last oxygen, so and so on. So what is going to happen? That aluminum is going to remain alone. I don't need this anymore. I don't even need this anymore. So what's going to happen is that you will have twice aluminum alone, because it loses every electron that it had. Every atom is losing 3 electrons, so loses 3 electrons, so the charge is 3 plus. Now what happens with oxygen? You have 3 oxygen, and every oxygen, it looks now like this. 1, 2, 3, 4, 5, 6, 7, and 8. These 2 atoms are coming from aluminum. That means that every atom of oxygen has 2 electrons coming from another element. In other words, it's gaining every atom of oxygen, every oxygen atom is gaining 2 electrons. So therefore, the charge is 2 minus, 2 negative. And now we build a Lewis structure. So it's going to be 2 outside the brackets, open brackets, write aluminum inside, close the brackets, the charge 3 plus, and now the number of oxygens, you have 3 oxygens, open bracket, write the oxygen there, close the bracket, and write a charge. And now inside you're going to include all the dots that are part now of your oxygen, that are right those. So aluminum loses its three electrons, that's why it's alone, and oxygen, as you can see, 2 dots in red means that it just gained 2 electrons, so the charge is 2 minus. Remember, losing electrons makes a charge positive and gaining electrons makes a charge negative, so the positive ones are called cations. The positive ones are cations, so you can write it there if you want. Cation, cation. Remember, cats are always positive. And the one that loses electrons, we can call them anions. Anion. And as you can see, an ionic compound is made of a cation and an anion, where the cation is written in the left and the anion is written in the right side, but that is for another class. Thank you for watching, guys. Bye.